Hey, so we today are still graphing systems of equations and seeing where they cross. But what we are adding in today is that some of our equations are in standard form. So the first thing that we need to do is we need to review the two different ways we learned how to graph standard form. So we learned how to graph standard form back in 2.8. So if you need to look back for more examples, your 2.8 notes and 2.8 assignment will be the place to look. There were two methods we used. The first method that we used was converting to slope-intercept form. So in order to convert to slope-intercept form, we did two steps, and we're going to do them here. So the first thing we did was we subtracted 2x from both sides because we're trying to solve to get y by itself. Okay, from there, we're going to have negative 3y equals So we got negative 3y equals, and then right here we've got negative 12 minus 2x. We are not going to subtract there. We're going to leave those separate. So we've got negative 2x minus 12 because we want it to be as close to slope-intercept form as possible. Okay. Then from there, we need to get rid of that negative 3. So we're going to divide by negative 3 right here, and right here, and right here. Okay, can you guys take notes with us now, please? Okay, on the left side, we've got y equals, and then right here, we've got negative 2 divided by negative 3. A negative divided by a negative is positive. And so negative 2 divided by negative 3, we were going to make it positive 2/3 x. And then negative 12 divided by negative 3 is positive 4. That 3 that I wrote does not really look like a 3. My bad. Let's make him look more like a 3. Okay, so that was one method we used to convert to slope-intercept form. The other method we used was finding both our x and y intercepts. A lot of people thought this method was easier. So for this method, we've got 2x minus 3y equals negative 12. We are going to take this 2x, we're going to set it equal to negative 12. For that, we are then going to divide both sides by 2. We're going to x equals negative 6. And we will graph that on our x-axis. And then for our other one, we've got negative 3y equals negative 12. We're going to set those equal to each other. So we set each term equal to negative 12. And then when we come to divide this one out, we'll divide both sides by negative 3. We'll get y equals negative divided by negative is positive, so this will be positive 4.
That makes hardly any more sense than what the first one did.
Okay, and that is fine because you can use one method or the other. You don't have to use them both. So we've got two methods of things that we can do to be able to graph. We are now going to, now that we've reviewed those methods, we are now going to go into graphing our systems. So the very first system we have, the first equation is 2x minus 3y equals negative 12. I did that on purpose. So we have the two ways to graph that here. So the first way to graph it, we could graph this, y equals 2/3 x plus 4. So we will start at 4, and we'll graph a slope of 2/3. We'll go up 2, right 3. And then we can go down to left 3 a couple times. And connect those. We could have also used our intercepts to graph. So if we're going to use our intercepts to graph, let me get like a highlighter or something. We would have just put a dot right here and put a dot right here, because this would have been x equals negative 6 right here. This would have been y equals 4 right here, and we would have connected those. If we are going to use the intercepts, it is important that you put your dots exactly where they go and connect them as straight as possible with your ruler, because you're only going to have those two dots to connect. So for this problem, we have now graphed 2x minus 3y equals negative 12. That is the one that is in standard form. Now we need to graph the other one. Instead of, we were thinking about giving you two equations in standard form, and we were like, hey, let's just give them one equation in standard form in each problem. So you're welcome. We never gave you both in standard form. So that's two ways to graph the first one. Now we're going to graph the second one. So we've got y equals negative 1/3 x plus 1. Thank you. We're going to start that graph at positive 1. And then graph a slope of negative 1/3. So we go down 1, right 3, down 1, right 3. I can also go up 1, left 3, and I see they're going to cross right there. So they cross right there, and then we write an ordered pair for our solution. It is negative 3, 2. Right. Any questions about that one? All right, let's look at the next one then. So for the next one, our first equation is y equals 2x minus 7. I can go ahead and graph that one because that one's in slope-intercept form. So the one that is y equals is the one that we're going to graph first. Or not graph first, but it's the one that's ready to graph. So we can start at negative 7, which is all the way at the bottom of our graph. And then our slope is 2. So we'll go up 2, right 1. Up 2, right 1. 2, right 1. All the way across our graph. Xavier, pay attention, please. You're going to regret not knowing how to do this in a couple minutes. Okay, so we're going to connect those. Yes, up to right 1. slope is 2 over 1. And then for our other equation, we have the choice. Would you guys like to convert or do intercepts? Or do you have literally no preference? No preference? Okay. I'm going to convert on this one, and I'll do intercepts on the next one then. So this one we are going to convert. So we've got 2x plus 4y equals negative 8. It's a two-step process. First step, we got to get rid of our x. So we're going to subtract 2x from both sides. So now I've got 4y equals, and then I'm going to put it in the order I want it. So it's going to be negative 2x minus 8. Okay. Then to get y by itself, we're going to divide everything by 4. It's going to work out. And we get y equals, does this equation work out? It's too early for this. Yeah, it does. Negative 2 over 4. We can divide both 2 and 4 by 2. And so that can be negative 1/2. So negative 1/2 x. And then negative 8 divided by 4 is negative 2. And so to graph this one, I will start at negative 2 on my graph. And then my slope is negative 1/2, so it perfectly crosses right there. Okay, and then this right here, our ordered pair is going to be 2, negative 3. Go right 2, down 3. 2, negative 3 is our solution. I'll write it bigger over here. Okay. Any questions about that one? Okay, we've got one more on the back. For the one more on the back, we're going to do the intercepts method. So go ahead and flip this over. We've got 6x minus 3y equals 12. That's our first equation. And we, again, are going to do the intercepts method. So I'll write down a note so I know that that's the method I'm using. We're going to solve two equations. So the two equations we're going to solve are 6x equals 12 and negative 3y equals 12. Kiki. Okay, so for this one, 6x equals 12. I'll divide both sides by 6. I'll get x equals 2. I can go ahead and graph that right here at 2. Okay. And then for this other one, I've got negative 3y equals 12. I'll divide both sides by negative 3. I'll get y equals negative 4. That'll get graphed on my y-axis at negative 4. connect those together. Then I am ready to go graph my other equation, the y equals 2x minus 4. To start graphing y equals 2x minus 4, I would want to start right here. And then my slope is going to be 2. So I'm going to go up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. What do we notice about those lines? They are right on top of each other. So these end up being the exact same line. So if you want to put a little note over to yourself that says same line, because they end up being the exact same line, this one has an infinite number of solutions, which we learned yesterday at the beginning. They are the same line, it's infinite solutions. Okay. Any questions right now?